In the vast expanse of the universe, millions of miles away from our blue planet, Mars stands as a lone sentinel in the cold darkness. Yet, this red world is not as solitary as it may seem. It is accompanied by two enigmatic companions, forever circling in its shadow, Phobos and Deimos. Named after the ancient Greek gods of fear and terror, these moons have long captured the imagination and curiosity of scientists and dreamers alike. Discovered in 1877 by the astronomer Asaph Hall, Phobos and Deimos immediately became objects of fascination. Unlike our own moon, which is nearly a perfect sphere, these Martian satellites are misshapen and irregular, resembling wandering asteroids more than proper moons. Their forms tell a story of cosmic violence and mystery, scars and grooves etched onto their surfaces by countless impacts over eons. Phobos, the larger and closer of the two, races around Mars with astonishing speed. Every 7 hours and 39 minutes, it completes a full orbit, faster than the planet itself rotates. This means that for any hypothetical observer on the Martian surface, Phobos appears to rise in the west and set in the east, streaking across the sky like a dart. Its rapid orbit sometimes brings it directly between Mars and the Sun, plunging the planet in a brief, eerie eclipse. A fleeting moment when a shadow races across the red sands, enveloping the land in darkness. As we draw closer in our imagination, Phobos reveals its true nature. It is a modest world, only about 27 kilometers long and 21 kilometers wide. Its density is surprisingly low, suggesting that it is not a solid chunk of rock, but rather a porous body, perhaps riddled with voids and weaker material. The most striking feature on Phobos is the colossal Stickney crater, a wound 10 kilometers across, almost half the moon's length. The impact that formed this crater nearly shattered Phobos, and the aftermath is evident in the deep grooves radiating outward, scars that snake across its battered surface. Deimos, the younger sibling, is even smaller, measuring just 12.5 kilometers across. Unlike Phobos, its surface is smoother, with fewer large craters to mark its history. Deimos orbits Mars at a much greater distance, taking over 30 hours to complete a single lap. Its movement is gentle and unhurried, appearing as a faint, slow-moving dot in the Martian sky. If Phobos is the harbinger of fleeting shadows, Deimos is a quiet, enduring companion. Though they may appear similar at first glance, Phobos and Deimos are set on dramatically different paths. Phobos, doomed by its proximity to Mars, is slowly spiraling inward, tugged relentlessly by the planet's gravitational forces. In 30 to 50 million years, it will reach its end, torn apart by tidal stresses and possibly forming a ring of debris around Mars, a ghostly halo marking its passing. Deimos, by contrast, is gradually drifting away, inching outward into the void. Someday, far in the future, it may escape Mars's grasp entirely, becoming a wanderer once more. The origins of these moons remain one of the great mysteries of planetary science. Did Mars capture passing asteroids, pulling them into orbit with its gravitational embrace? Their irregular shapes and carbon-rich surfaces lend support to this idea. Yet, their nearly circular orbits and alignment with Mars's equator challenge the asteroid capture theory. Alternatively, perhaps Phobos and Deimos were born from chaos, a massive impact on Mars long ago, hurling debris into space that eventually coalesced into these tiny moons. Models of such collisions show how material could settle into stable, equatorial orbits, mirroring what we see today. The debate continues, fueled by new data and ever more sophisticated simulations. If these moons were captured asteroids, their orbits would likely be more eccentric and tilted. The giant impact hypothesis, meanwhile, provides a mechanism for their current trajectories but struggles to explain their composition. Some scientists have proposed a hybrid scenario involving icy bodies colliding with Mars, mixing rock and ice to create the moons we observe. Human exploration has played a vital role in unraveling these mysteries. Early missions like Mariner 9 and Viking offered grainy glimpses of Phobos and Deimos, teasing our curiosity with their indistinct shapes. Over time, technology advanced, and spacecraft like Mars Express and the Mars Reconnaissance Orbiter delivered crisp, detailed images and spectra, revealing craters, grooves, and the subtle differences in surface composition. The Emirates Mars Mission, Hope, has added even more layers of understanding, helping to map their motions and study their chemical makeup. Comparing findings from different missions, scientists have constructed a more complete picture. They have measured the moon's densities, mapped their orbits, and analyzed the minerals on their surfaces. Each mission has brought us closer to understanding not just Phobos and Deimos, but the processes that shape moons and planets throughout the solar system. Looking ahead, the future of Martian moon exploration is bright. The Japanese Martian moons exploration, MMX mission, is poised to make history. Its goal? To land on Phobos, collect samples from the surface, and return them to Earth. For the first time, we will have the opportunity to study Martian moon material in our laboratories using the most advanced instruments available. These samples may hold the answers to questions about their origins, evolution, and the broader history of the solar system. But the significance of Phobos and Deimos extends beyond scientific curiosity. Their low gravity and strategic location make them valuable stepping stones for future human missions to Mars. Imagine astronauts landing on Phobos, establishing a base, harvesting water ice to produce fuel and life support resources. These moons could become way stations, places to refuel, shelter, and prepare for the challenges of exploring the Martian surface below. Standing on the rugged terrain of Phobos, or gazing up at the gentle arc of Deimos, one cannot help but feel a sense of awe. These moons, named for fear and terror, are not mere obstacles or relics. They are keys to unlocking the secrets of Mars, the solar system, and perhaps even the origins of life itself. As our technology and ambition grow, so too does our ability to reach these distant worlds, to touch the past and shape the future. Phobos and Deimos continue their silent dance around Mars, casting fleeting shadows and gentle lights across the planet's surface. They remind us that even in the cold reaches of space, mystery and wonder endure. The answers they hold may one day guide us as we venture further, forging new paths among the stars and discovering what it truly means to explore